couple of quick announcements, and thank you for staying to the end. I think actually this session is going to be, I think this day is already proving to be exceptional. Want to say that those people who did yoga and had the workshop with Fran, I guess she has a personal present for you or something like that. So if you could just report to Fran. But we're going to go.
5K runners.
Yes, okay. We're going to quickly go on to the quick abstracts. If you could present it in 3 minutes, and we're going to give you a couple of minutes of questions, and we're going to go right to the entire faculty. We still have space where no one wants to sit in the middle. Okay. If we're faculty the last couple of days and you're available, please come on up. We want to really make this a full panel for a good, robust 30 minutes, all right? So let's have the first abstract, please. Again, these are winning abstracts, so let's give him a round of applause, please.
My name is Ola Sharma, and thank you so much, Dr. Anthony. This is my third year here. And last year I presented a project that was how to differentiate between the good image, the good painting versus the fake painting. So this one turned out to be an extension of that project. So what happened basically, I collected a lot of the Vincent van Gogh paintings, and I created a model that works well, but that was not very well generalized, and I started finding some other paintings also, and I had some difficulty with the accuracy. So I came across this noise-to-noise research paper, which has been created by NVIDIA, Aalto University, and collaboration with the MIT. So when I seen that, then I realized this is going to help me a lot. And so with this research paper, what happened? The specialty of this paper is we don't have to have the good images in order to make the good images. So all the bad images or the noisy images, grainy images they can be converted to the good images. So that was my baseline. And I turned some of the paintings to the good painting, which has been like the hundreds of years ago they has been created. So they worked very well. So in terms of algorithm and the training, as I have described here, the 50,000 images has been taken from the ImageNet, and it has been used with the different synthetic noise and Bernoulli, the Gaussian noise, Poisson, and some synthetic Monte Carlo images. They had been tested very well. And it turned out to be like, here is the one example, which is it is very close to the ground truth image. They have made this noisy input. This is synthetic, but the results are very, very, very outstanding. So here is a little video, just a few seconds, I guess. You will see. So this is very, 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 very clear. This was another one, which is the model is building like really very clear. So as extension to this, I'm implementing this and trying to make this available very soon in one of my websites called deeplearning.buzz. That is where I put all my stuff, whatever I learned. Basically, I try to make the research paper, the good ones, make them practical. So I just learned I have the coding skill from, 18 years of experience of the web development. So I have done a lot of things, and from last 3 years I have been in the data science space. So that is a good match actually. That combines very well. So I can convert to any research paper to the real world example. So this is one of them. So as another extension of this, I found that this could be done with another project. So I got some images from the NASA website, and those images has been taken by the robot which they send, and it takes very long time to get those images if their quality is very good. So they're taking all kind of images, the good images, the bad images, and we can get those images, make them better here, and figure it out what is over there. So that was the one extension with this. That is the huge use case.
Why don't you just highlight it for us? So we want to
Here,
wrap up
here you see like the clean target and the noisy target. Here you see they are very similar. And the third one is the noise to noise. So the noise to noise, the model is like really better than the other ones. Here is another use case for the MRI scan. So we have the one noisy input here. I will not go for much detail on this because I'm not qualified for this. I'm just programmer. But you can see this is how clean it is from the left one MRI scans to the right one.
My name is Stephanie Harmon. I'm a postdoc imaging physicist turned data scientist within the molecular imaging branch of the National Cancer Institute.
My name's Tom Sanford. I'm a clinician who has the deep distinction of sitting right next to Dr. Harmon here.
So first I'll just briefly orient you to our clinical problem, which is the pathological grading of prostate cancer. Currently this is done with the Gleason grading system, which was actually first introduced in the 1950s and really has only had minor modifications since. It does well at its extremes, which is why it's still in use. However, there's poor inter and intra-observer reproducibility, and in the intermediate category, which is where we make critical decisions about patient therapy, really we have a very heterogeneous, both in the biology as well as in the pathology, group of patterns and patients. So we are partnering with Jesse McKinney, who is a pathologist at the Cleveland Clinic, who has really championed the idea that we need to move beyond the Gleason scoring system and really characterize the full library of architectural morphologies that are observed within prostate cancer. And so what Jesse has gone through and done is characterize, as I mentioned, this library of 21 different patterns. He's shown that they correlate with outcome independent of the Gleason scoring system. But the big problem is it's impractical to ask pathologists to identify these patterns in their clinical workflow. So it's a great use case for AI to go through and classify these patterns. So we're working on 17 patients, which actually is 53 whole slide images. If you're not familiar with digital path images, these are massive, massive images. So we're working actually at 20x scale. Usually this is about 100,000 by 100,000 pixels. And Jesse was able to go through and annotate about 5,000 different regional classifications that encompass these different patterns for us.
So we've heard a lot of that about 90% of the work is in the pre-processing, the image processing. So Dr. Harmon did all of that, and then she allowed me to do the really fun deep learning part. So I wrote some Python code to wrap the FastAI library so it runs on our cluster, and then we trained 3 separate models. And the 3 separate models had different outcomes. So there was the full, really granular 20-class system. There was a 3-class system, which is kind of more familiar to us as clinicians because that's what we have now. And then there's a 6-class system that really helps us with this intermediate group, the group that we really struggle with clinicians. So once I kind of wrapped this all up, I gave it back to Dr. Harmon to train the models.
So we spend a lot of time thinking about what the pathologist sees in these images and what the network sees in these images. And so if you're working with a pathologist, they'll tell you, on an H&E image, they're actually looking at the H and the E stains separately. They want to see what the nuclear distinction is and the stromal features are. When you think about a network, it's looking at an RGB image, which is great. We can use transfer learning in this setting. But really, it's not recapitulating what the pathologist is seeing. So what we then do is some advanced image processing where we can deconvolve the images now into these stained channels, combine it with a black and white image, and now we have a deconvolved image that we can feed back through our network. And what we saw, just in general, we had good out-of-the-box performance on our classification task for all of our different systems. And we reliably observed actually a 2 to 5% bump when we used our deconvolved image. And in deep learning, we know data augmentation is important. And I think in biological imaging, our take-home message is we have to think how data augmentation can be specific to the images that we're working with.
If you're not impressed with 75 to 85%, just keep in mind pathologists disagree with each other up to 50% of the time. So
We're too hard on the machine sometimes.
sometimes we're
right,
too
as I
hard on the
always say.
machine. So, just to drive one point home, for those clinicians here, we go to conferences, we see some great clinical papers, and we think, well, wouldn't that be great if we could use it? But keep in mind, it took 20 years for Gleason score to be widely adopted. So if we have a new system that we think may be a little bit better, something like this, a model that we can train that can help implement these new papers, these new good ideas, can be really helpful.
Great. When I read your abstract, not only was I impressed with the level of work, but also collaboration. That spirit just kind of leapt forward from the page. It was just amazing how it was obvious to me that you did a lot of work together. So just I think a shining example of collaboration and people looking for each other to do good work. It's just an amazing example of that. So I'm going to give you a small token of our appreciation for your work. And we'll also probably feature you in a magazine coming up. Good job. All right. I'm going to put up a few slides just to kind of frame our last forum. Thank you, AV team. Okay. Yeah, that was fast. Okay. Maybe I should have waited until I finished my presentation. Okay. So a few thoughts from yesterday. This morning was just amazing. I was just taking 2 pages of notes, and I'll share it at some point. But I thought it was really amazing that Joe mentioned that he's an engineer and he's doing a patient safety movement, and I'm a physician and I'm working on a machine intelligence AI movement. So it just goes to show that when you step out of your domain, maybe the dividend is pretty amazing. So, and also, I think Dale mentioned that we need a moonshot mindset for AI. I have an answer to that. I slightly disagree with you. I love disagreeing with a lawyer. For AI in medicine, for multidisciplinary collaboration, totally get that. We totally need to do that. Another point is we need to start working with the FDA as well as the AMA early in development process and just demystify this black box concept of artificial intelligence. And lastly, that the tool should not just be used for imaging. We saw 2 phenomenal examples, but let's also focus on other non-image related problems that we discussed in a lot of detail during the meeting. We'll go to the next slide. Okay, so a few predictions, because someone asked me to talk about that, and we'll look for a response here. So my younger daughter went from 1 to 2. I felt like this year's was that growth and development. So what are we seeing in the future? And this is her just a few days ago. So it reminds me of the fact that for AI medicine, we're sort of at the Wright brothers stage, and we need to, at some point, get to this stage. And I think we'll get there. We'll just have to create the future rather than wait for it to happen, as we all been saying. And I think Jeff mentioned that too. So a few things. Healthcare data, I think I'm predicting that at some point we're going to need to transition to an entirely new type of database and get rid of our relational database. And that's the hypergraph that you've heard from, I think, Spiro Mouzes. Another prediction is that the entire AI architecture needs to change, and we're going to be increasing both central, i.e. cloud, as well as peripheral intelligence. So everything that Tim talked about in terms of embedded AI, EAI is another term, or IoE, Internet of Everything. I'm also predicting that we're going to change, just as we're comfortable now with deep learning, we're going to say it's not good enough, and even the deep learning gurus are saying it's not good enough. So we're going to be shifting in the next 5 to 10 years to include more cognition elements in AI. So what Joseph Voss says is the 3rd wave of AI, which is the cognification stage. And that's going to give us a much, much bigger dividend. All the complex biomedical problems, I think, will be at least partly solved with an entire paradigm shift. I personally think, as with Leo Celli, having the dual education and perspective is very important. I'm a big Formula 1 fan. You see there's the racers and then the engineers. There's actually been one single person who was both a Formula One driver as well as an engineer out of Caltech. He is so famous, I don't remember his name. But he's not well known, but you know what he did? He made a major contribution in the design of the Formula One car. He's the one that designed the rear wing that you see in all Formula One cars now. So again, not many people know about him, but he was the only combined engineer driver that's in the history of Formula One. And I think we need a cohort of clinician data scientists to be able to converse both languages. And I'm working hard on encouraging that process. And lastly, I think there's going to be an emergence of intelligence groups in hospitals, perhaps even chief intelligence officers in all the hospitals. Rather than chief information officer, the new CIO should be chief intelligence officer. And that we're here right in the middle of the hype period, and we're going to need a lot of patience to go beyond the hype period, and that's when we have dividends. And then one of the things I learned from our faculty in listening to these discussions is that I think AI will really enable us to learn more about ourselves as clinicians and patients, because after all, it's not really artificial intelligence, it's what we teach the machines to do. With that, perhaps someday we'll need to change even the name of this meeting and how we look at things. Here's human intelligence and machine intelligence. What if they just we blur the boundaries and it just become medical intelligence, and we don't worry about the differences between machine and artificial intelligence? At least that's my dream someday. And always go back to history when we think about the future, right? So Alan Turing, really inspired by my visit to Bletchley Park, thank you, London, for that opportunity. He said 58 years ago that we can only see a short distance ahead, but we can see plenty there that needs to be done, which I think is so appropriate for AI in medicine. And this is a slight disagreement with Dale. I think we had the right idea in mind. Rather than thinking moonshot, let's think about a Mars shot for AI medicine, because it's going to be a long journey. You remember 5 or 10 years ago when people started talking about going to Mars, people were still giggling on TV, talking about it. Guess what? I think people like Elon Musk is making us feel like this is actually achievable in our lifetime. So I think maybe perhaps someday we'll have a meeting on Mars. I haven't told you that, Freddie, yet, but we could be the first conference on Mars. Okay. Okay. Yeah, I'm killing him slowly. Okay. I want to always thank my amazing donor and foundation that funds a lot of these activities, and my very patient mentors and classmates from Stanford. And again, here's the website that's available. We're going to keep putting resources there available for everyone to use for free, because it's a movement after all, not just a meeting. And as I said, these are some of the cities that we're interested in going to. We're also going to have a series of breakfast meetings for you. So if you're from a particular city, contact either Freddie and I. We'll put it on the list of cities that we'll be visiting. It's just wonderful to visit you in your own venue. We'll come to you, in other words. And again, my little girls are really happy this meeting's ending, so they'll see their daddy today. They wanted to wish everyone a happy holiday and have a very safe trip home. Again, I think the main thing I'm thinking about all of this is AI is an amazingly shiny, attractive ornament, but let's fix the tree too, all right? So with that, we're gonna go around very quickly. Last thoughts. What's the one thing you think you want people to get from this meeting as a takeaway? Think about that question. It cannot be like 5 minutes. So just like it's almost like a tweet, all right? So we'll start with Gio. Use the microphone, please. Oh, yeah. For a tech-savvy person.
I'm sorry, the tech is the real play. This is just talking. So I think throughout this journey through AI Med, we have to be truly the supporters of the new generation coming. And the more I meet from the abstracts, they're not jaded. We're jaded. And that, I think, is going to be the biggest breakthrough for us in AI Med.
Amazing insight. Hey, you skipped George. George, what do you think?
Well, just one day that AI med gets integrated into medicine, I guess. AI med gets integrated into medicine.
Sounds familiar. Okay. George, you're a smart kid. You'll be able to do a lot, just as much as your brother someday. So,
I think the biggest takeaway from this should be that in order to make the most advancements, it all comes down to one basic thing, and that's awareness. I find it crazy sitting here today that just 3 months ago, before I started the MI3 summer internship, where I learned all about AI, just 3 months ago, before I started the internship, I had no idea about the implications AI had on healthcare. And that's crazy sitting here knowing that it's a huge part of my future. So I think the biggest thing that we have to support is just the awareness of AI, especially for my generation. And that's going to be my personal mission going forward, just spreading awareness to my peers about the implications of AI on healthcare in the future.
Iman?
Thank you. I think we have to keep in mind always that the journey to making technology mainstream is a long one. And we often think of, we know what the destination looks like, what the technology is going to look like when it's implemented. But I believe it's about the journey, and that we're going to discover a lot of things along the way that the destination might look different in the end.
And as Bill Gates says, we over-expect the short term and under-expect or under-appreciate or underestimate the long term, which I think is certainly true for AI. Sean?
Absolutely. See, I got this one. Okay. I like the comment that the technology is here. It's just not evenly distributed. Yeah. So not all of us are going to be ones who are making new technology and new innovations, but certainly all of us can be part of the distribution and the even distribution. So figure out how individually you can do that, and I think we can distribute this technology that's already there.
Good one. Tatiana?
When I was at Pricewaterhouse working there's someone from Oracle in SAP practice, I realized that there are two types of people that I was working with: technologists and business processes people. And Nirvana came when we partnered those people and applied technology with knowledgeable people in business processes. So at that time, I built 2 courses: technology for business people, business processes for technology people.
Yep.
It was okay, and you mentioned partnerships. So what I think the biggest takeaway should be that you practice medicine, different areas of medicine. So you don't need to be scared by all those terminology, blockchain, AI, neural networks, NLP, and all of the above. However, you can partner with technologists and create those partnerships that will benefit us all. You need to understand, but you don't need to go and think, oh, I need to learn Python tomorrow.
Take one out to lunch and just meet somebody. Yeah. Okay, Prasanth?
Yeah, I would like to also echo the power of community, actually, that, so we all are solving biggest problems of, healthcare. So, we all need a community support, actually. And AI Med offers that platform where we come and discuss the problems and find solutions. Biggest companies in the world were built by connection, how 2 people came together and then a spark happened and then the solutions came out. I think AI Med will, continue bringing great minds together and fuel the innovation and the change, the history of the world.
Well said. And we always end up somehow with about half and half, which is pretty good. And it's ironic that last year some of you were here, remember the clinicians insisted that we don't bring in more clinicians, which is a funny comment. So, Dale?
I'm going to make a statement that's going to sound maybe a little bit obvious, but I think focusing on the obvious makes a lot of sense, which is to focus on economically viable use cases that fit within a clinical pathway.
Yeah. Really need to put that, write it down, and for entrepreneurs, just post it somewhere so you read it every day, because you get distracted by all the technology and end up with a bad business plan. Jeff?
I want to comment, I'm inspired by the successes that AI has had, and then we've seen a number of examples of where this really can work, but point out that each point solution for AI needs to be incorporated in an experience that people have, that ultimately it's the end-to-end experience of getting healthcare that needs to be improved. I commented in my talk about the problems, but I see in the future that we're going to have healthcare that is convenient, that is more efficient, that is directed in a way that actually works, and that actually leads to outcomes, far better outcomes for the energy and effort we put into healthcare.
Well said.
I think that to be successful in the future in using these tools, clinicians and other members of the healthcare teams will have to reimagine our work. And I think that innovators that are developing solutions need to keep that at the forefront of their thinking as they're interfacing with clinicians and developing solutions.
Yeah, I talked a little bit about reconfiguring the radiologist job description. I'm actually predicting that within 5 years, well, I may even end up with more radiologists, not less. So I always have a public debate with a certain person. Steve?
Just two comments. I would love the day when computers and humans could work together constructively in sync to solve problems. And the second, I truly believe in this commoditization aspect. When I type on Google, it tells me what I'm searching for by guessing. When I go to Amazon, it says what you really need is this item, not this item. And so what we need in healthcare is when, you know, I sometimes use this question, when's the best time for the ambulance to arrive at your house when you're having a heart attack? And the answer is 2 hours before you have your heart attack. That's what AI is going to do for us.
Great. Diane?
Yes, thanks for including this clinician, at least this time. It was really great. I have two quick comments. One is that I think the failure of AI so far has been that we have not included the patient enough in creating these worlds. The patient is not their disease. The reason that it's been so successful, transportation, entertainment, and finance, is that it was all created for the end user, and the end user was the one who was really promoting that acceleration. And we really need to have not just a patient up here talking, but a patient creating and being part of that. And the second point I'd like to make as far as medical school is we use a lot of AI guidelines and so on, and then there's the point where it does not answer what that patient has. I have this classic example of a fellow turning to me after going through all the basic coag tests, looking at a patient covered with bruises saying the tests are negative, so I guess they don't have a bleeding disorder. We have to teach our medical students, our physicians, to think beyond, and this is where the issue of connectivity, I want that person to learn how to connect to the basic science so that they know how to solve and make a new diagnosis. If it's not in a guideline, it's still a problem.
And not be a victim of automation or machine bias.
Or just not thinking.
Yeah.
We have to continue to think ourselves.
Yeah.
So.
Anthony, if I'd like to add one more quick comment, which was I described how doctors have participated with us in creating a platform to help people at a global scale. Actually, there's 4 or 5 of those doctors are actually with us here today, and if there are clinicians who'd like to understand, we're going to meet right after here, probably go to lunch together. If people want to meet other doctors who are actually participating on this, you're welcome to join us.
Yeah, I always say that almost everything on the AI and medicine agenda is human to human, bonding, meeting, discussing, executing, and it's not machines getting together. Well, at least not yet anyway, so we don't know. Okay, Sharif?
You know, Sean was saying earlier that in the intelligence community, it took this sort of this really bad event to really bring the community together. And I think we're at a point in healthcare where it is so dysfunctional and there are so many disparities and there are so many challenges within the healthcare system. I don't know if we need that event. I think we just need to take that oath and take that leap now. And we're in the right place at the right time to just do it. So not to be a Nike commercial, but I think this is the time to just do it. Do the AI in medicine and make it happen and help the next generation keep moving it forward.
No, that's a great point. I actually, believe it or not, I actually give a talk on the difference between medical intelligence and our military intelligence. And one key difference is that we're probably never ever really going to have a 9/11 moment, unfortunately in a way. as catastrophic as that was, but it almost took that kind of magnitude of a disaster to really galvanize everybody without question, right? So, but on the other hand, thousands of patients are dying every year. We just don't, many more than 9/11, and we're not, it's just hard to get into the problem, the crux of the problem, when you don't have a public event like that. So with that, I want to thank our faculty. I feel funny calling you faculty when a lot of you, or most of you, are friends already. And I want to thank all of you for staying to, I actually don't know how many of you are there out there. Is it an empty audience by now? Okay. Okay, there are people out there. Okay. Thank you for staying. And is Shahab from Children's Hospital still here? Shahab, are you here? Okay. The $80 million No, just want to thank, again, the hospital and my donor for just giving me the flexibility and time to do things like visit you, put things, meetings together. And my partner, Freddie White, he hates standing up and saying thank you, but for his team, Priya and Megan, and just an amazing team. And if you look at the faculty, I think we finally achieved what we were shooting for, which is equity at all levels. So thank you very much. So have a very good holiday and a very safe trip home. So we'll see you next year or sooner in 2019. Thank you. Thank you. Thank you.